So now in today's class, these are the things which we are going to cover. Some of the things I'll cover today, and the next things I'll cover in the next slide. So where MapReduce is used, we'll also look at the traditional ways of solving the same problems which we used to do when I was young. Okay, and we will also look at MapReduce way of solving a problem. We'll also look at how does a MapReduce program look like. Okay, we will show you in Java, we'll show you in Unix also how did we used to do the same thing earlier. Then we'll also cover Hadoop streaming. Okay. So Hadoop streaming is the way in which you can actually write MapReduce program if you do not know Java. Okay, so all the people who are from Ruby, C++, Python, Perl background can be a little happy because I'll teach you how to write MapReduce without knowing Java. Okay, we'll use a couple of languages and then I'll leave it to you. So you'll have a lot of assignments there. Okay, great. Then we'll also look at what is a combiner and a partitioner. Don't need to worry too much about it right now. These are terms which you just need to remember. Okay, that there is something called a combiner, there's something called a partitioner. I will go into details why it is used, where it is used. We'll also show you the classes in Java which have where this is implemented. We'll look at the MapReduce data flow. Okay. We'll also talk about input splits, how they're done. And then we'll look at the input-output formats. Okay, so this is important. There now we know we have unstructured data that can be in many formats, right? So it can be in. So these are the defined formats. For example, there is a text format. There's a key value text format. Okay, we will be also looking at nline. Okay, we will be doing MapReduce too. Okay, and sequence files will be for images and audio files there. Okay, so we will be looking at each of these things and. Don't have to worry too much about anything right now. It will be very simple. It's actually very simple. Okay, it's not difficult at all. Okay, so where is MapReduce used? Okay, so we have a lot of data from the weather forecasting. Okay, where we have a lot of climate data, which is say from since the beginning of the century. We need to analyze what is the what will the maximum temperatures. We'll do a lot of predictions based on that. So that's one place where we'll be using MapReduce. Can you tell me where in healthcare will we be using? Okay, patient reports, auditing, product distribution, right, claim processing, right, ECG monitoring, machine data flowing into in the tools, says Vamsi, right, identifying fraudulent claims, okay, DNA research, Sachi, right, that's true. Scanning data. So yeah, so there are a lot of applications. We have a lot of unstructured data from all these industries, and these are not the only industries. There will be a lot of other industries where, say, utilities side, oil and gas industries, right? We'll have a lot of data which we need to analyze, and we'll see how we used to do that earlier. Okay, now, okay, so we'll just see how we used to do earlier, and then we'll see what are the challenges there in the earlier methods, and then we'll see how Hadoop and MapReduce solve that problem. Okay, so let's look at one of these examples. Now what I've done is I've picked some data from this site, NCDC, this is climate data, okay, and so this has for each of the years, right, it has the data here. Okay, let me show you some of this data, how this data looks like. Okay, so that was on the PPT. Now let's see this data. Let's see where I got this data, and we'll see what do we do with this data. Okay. So let's look at year 2013. Okay, Rahul, are you able to hear me now? I mean, I think there may be something wrong at your end as well because everyone else says that I'm audible. Okay. So this is one data set, huge data set. So there'll be such data sets, and I've just picked up one from that file. There'll be terabytes of such data. Now look at this data. It's like a log data. Lot of columns are there, and it is delimited by space and tab. Okay. So you don't have to worry too much about what are all the fields here. The whole idea is to present it to you. Yeah. So if you want to see what all is there, let's see what is there in this data. Okay. Yes, it is. That's right, Ashish. Okay. So now it says that W-band number is something which we do not care too much about. Then there is this local standard time, which is from columns 7 to 14. We have columns longitude, latitude, daily max temperature, daily min temperature, daily mean temperature. So lot of such data is there here. Okay. Now what we want to do probably with this is that in this, if I have to say find what in every year, right, what is the maximum temperature which occurred, or how many days can be classified as hot days, how many days can be classified as cold days, right? So can anyone tell me how will you find it if this I mean, forget about Hadoop, right? How will you actually find it out? So if I have to tell you that for each year, give me tell me which is what will be your traditional way of finding it out? How will you do that? Yeah, the columns are fixed, Vamsi, right? That's true. Okay, so Sachi is telling you we'll load data in Oracle and SQL it. Okay, go through in row and column value, max function, right? Right, Vinay. Okay, and evaluate for a range. Okay, okay. Is anyone from the Unix background here? Yeah, great. So Ravi has given me some answer there. Very good. So Arka has given me a very good answer. Okay, put it in a file using awk. Very nice. So that's what Rajat has also given me the same answer, awk. So how many people know about awk AWK? Everyone knows about awk? Yeah, Avinash, you can write a script in Perl as well. Great. Okay. Okay. So don't worry, whoever does not know about awk, okay, that's not really required in this course. But what I want you guys to do actually is, I'll send you some code in awk as well. So what we'll probably do, see the whole idea. No problem. Even if you are from the mainframe background or any background, doesn't make much difference. Okay, so it is very simple. So in Unix, if I have to take this file in, what do I have to do? You see, the fundamental thing will be that for each record, right? For each of this record, which has one record, which has, say, this is the maximum, this is the minimum temperature. I have to loop through this record, okay, and figure out put this into a max temperature thing, and see if as I go further, whenever a max comes in, you know how to write a program to get this done, right? So awk or Perl or these are scripting languages which can be used for record-oriented data, which can quickly do those things, right? So awk will be the fastest, Perl will be slightly slower, but will be again very good for this kind of thing. You can do this in Python as well. Okay, so does everyone understand what we're talking about here? Is there anyone who has no clue? I know a lot of people have understood, but anyone who has no clue can tell me? Okay, everyone, most of the people have understood. So now if I have to figure out, okay, Amrish is saying he has not understood. So okay, Amrish, let me make it very simple for you. Okay, so now this data has a lot of records, right? Each line is a record. Now each line, this column is one value, then this column is another value, this column is another value. This column probably is the date. Okay, this column is the maximum temperature, this column is the minimum temperature on that date. Okay, and if I have to figure out that what I'll probably do is all the remaining I don't care about, because I just need to look at what is the maximum, the minimum temperature on a particular date, right, or on a particular year, right? That's what I'm looking at only. Okay, so if I have to look at that, all the other columns I can ignore. I can just look at these columns from each record and then do some processing to figure out whether it is the maximum temperature in that year or not. Right? Is it making sense at a theoretical level? Is it making sense? I'll show you how to do that. Great. Okay. So yeah, so everyone has that idea. Good. Good, Ravi. Thank you very much. Okay. Now, what I also want all of you guys to do when you go back home is to look at how does awk work. It's a simple language, okay, very, very simple language, but though you may not be required to do that, but it's always a good skill to have. When you are working with data, learning awk and a little bit of Unix is very, very, very handy, right? And I'm sure my friends Ravi and other people who have worked on Unix, or maybe Dilip is a Linux administrator, I believe. Dilip, you are comfortable with awk? Can I quickly get that answer? Great. So what I want you guys, whoever is comfortable with awk, is to write a program in awk. Arka, don't worry about those values. Okay, You don't have to worry about all the values which are there in the record. I also don't know. We just need to pick up some values. You can read this readme file to figure out what all does this contain. Okay. For now, let's concentrate on these three values. Okay. Now, whoever knows awk, I want them to write a program in awk, okay, and send it across as an assignment, okay, to us, in which we will give you this one of these files, and you have to use awk to write the same thing which you're going to do in Java today. Okay. Is that fine? Everyone who knows awk, can you quickly give me a yes? Great. And we will be sharing that with everyone else in the class. Okay. So I want you to write this by tomorrow if possible. Whoever gives me the first answer, Dilip and everyone, whoever gives me the first answer gets some bonus points. Okay. So great, Sachi. So sure. And other people who do not know awk, I want them to Google a little bit on awk, look at this data and try to create a program in awk for doing this work. Okay, to find out the maximum temperature here. Is that fine with everyone, guys? We will be sending out the awk program as well. So by Thursday, I will wait. If I get an answer from everyone, then I will not send anything. Otherwise, I will write one and I'll send one. Okay, fine. So we will learn with each other then, right? So now coming back to the slide. So this is what we used to do earlier. Yeah, we will be sending you the input files. This data set is available. We'll be sending you the link to that. Okay, so an input file I'll send you. Okay, I'll also, yes, Rajat. So I'll also send you the exact problem statement just after the class. Okay, so don't worry. Okay, now so this is what we used to have, and as you have told me that you could use awk to do this. So then if we could use awk, what is the problem then? Why do we need anything else? When I am so much, I'm a big proponent of awk. I am a big proponent of Perl as well. So why do we need something else? Amrish, what could be the challenge there? Okay, large number of files is what Vamsi says. So large number of files can be done. Portability is, yeah, data volume with limited data set. Okay, yeah. So basically all those reasons which we had to adopt Hadoop. Okay, okay. So Sachi is telling you market is hot with Hadoop. So samay ke saath chalo. Yeah, that's a good answer, right? But okay, but the fact is that you can do a lot of things with awk. Now the challenges are that, and I'm sure you will yourself figure it out. So what I'll probably ask you to do is write the awk program to run it on a small data set, which is one of these. These are few KB files. Now when it becomes terabytes, right, then the problem is that as we saw right from the first class when I was telling you what is the challenge in the world, not storing data. It is reading it and analyzing it, right? You remember that thing which we showed you in the first class itself, where we showed you the time to read from a single machine versus time to read from a distributed fashion. Everyone remembers that figure? Right, seek time is the problem, right? So that's why awk also, or any such program, will have a problem. So what could be the probable solution for that? Even if we have, so we can split that data, right? So if I had so many files, I could split this data, do a grep, or I mean, I've made it very simple. We did not need to do any awk. We just need, you can do grep also. For the people who do not know grep, please look in. Grep is the command to take out a few regular pattern from in Unix. Okay. So whoever does not know grep, go do a googling on grep as well, right? So if we had, as we saw, right, if we had huge amount of data, what would we do? This is your very big data. Now, one of the files which we saw was this data only. So what I'll probably do is split this data into multiple files, okay, and then do grep on each of these. Whatever matches, do a cat and create a final output, right? All matches can come here, right? So is it making sense? That will be that obviously the next thing which you would think of doing. Is that correct, guys? Anyone who is not with me till now, just say no. Everyone is with me? Great. Now you have to tell me, the next question I'll ask is, if everyone agrees with this, then what are the challenges in this approach? Can someone throw some light on that? What are the challenges in this approach? The approach is very simple. You have very big data, split it into multiple data sets, run it on different machines. Okay. Splitting the data. Okay. Time consuming. It was time consuming. That's why you split it, right? So Don't worry, Orca, what pattern? Let's just, yes. So one very good thing which Dipankar has told me is, yeah, reliability is one answer which I've got. Guys, yes, very important thing, reliability. Failover mechanism is what Dipankar is telling me. What else? Is there anything else? Computation is not done, Avinash, at one place. We can compute it at multiple places also. So the solution is simple, right? What I've done is, what I'm saying is, all this, you split this data, put it in different machines and do that thing. Do it parallelly only. Now I'm not saying that do it in sequence or in single machine. I have agreed that we can do it in parallel. So you have said 1 terabyte of data, okay, split it into say 100 parts, and then do grep on different machines and then do a cat. So this is feasible, right? That's what this is feasible. If I had to do these two operations, this is feasible, right? Great. So now I want to know what are the challenges in this approach. Why do we need something else? Something which has taken the market by storm. So Vamsi, see, Hadoop is also working on Unix only, right? This can be done in other things also, other languages also. Unix is one way of doing it. I mean, similar things will exist in other languages as well, right? Other platforms as well. So that's not really the thing. So why did we, if we could do this here, okay? Okay, so now Rajat has given me one answer. Okay, Tush, okay, great. So Rajat is saying failure on one machine can corrupt the entire matches. Right, so that's one good answer. Okay, it is not robust as Tushar is saying. Tushar is saying the job to split and integrate after CAT is still a manual process. Well, my friends Dilip and Ravi will quickly create a script for that as well. That should not be a big problem. They can do that. But then yeah, I've got very good answers now. I think most of the answers I've already got, right? Orca is saying instead of reading record by record, it will be read block by block. Okay, fine. But finally you will be doing a record. It will be read completely block by block. But when we do a analysis over it, it will still be a record by record analysis, right? And we'll show you that. So that's not really the reason. See, have you ever heard about critical path? Everyone knows what is the critical path in a, okay. Okay, some people have, some people have not, right? I'm sure whoever has done a PMP exam, they would have, that is the first thing everyone will know. But you don't need to do PMP for knowing critical path. See, critical path means that, okay, Ravi, yeah, great. Okay, okay. Yeah, yes, Ravi, right. Sachai ko certificate ki zarurat nahi hoti. That's true. So don't need a PMP to know critical path. You can know critical path and still not be a PMP. Okay. But anyways, you don't need any, see, the reason I'm putting this thing here is that one very important thing is that now it will also depend upon the machines which you are using, okay, and their processing capacity of each machine, okay, will be important here when we are splitting this data, right? And if a machine is, one of the machines actually is a smaller processing capacity machine, then that will become the critical path and it will delay the process for everything. Is this making sense to everyone? Say for example, this grep is done very slowly. All these were ready. This took 2 hours more. So everything took 2 hours more, right? Is that, yes. So, right, is that making sense? So that's what critical path is. So anything, now I want Ravi, who is a PMP, to define critical path for me, and I'll read out that definition so that yeah, Ravi, I want you to actually speak if you can, if you have a microphone. Okay. So Ravi is saying I'll not tell. Who's going to define critical path for me? I mean, you have Google as well. Everyone can go to Facebook and look at that. But you have to define. Samrish has gone there. Rahul has gone there. Ramesh, Ranjit, Vamsi, Vinod, all of them have gone there. Other people, Shriram, you already know what a critical path is? You might as well appear for the PMP exam after this class, man. Because you're going to know What a critical. See, how many of you are actually managers? Very good. Rajat has given me the right answer, and he's a okay. Okay, Ramsey, don't worry, you can check on your mobile. Okay. So Rajat says I'm PMP certified. Congratulations, Rajat, for that. And it's a good thing to. No, I can't trace mobile phone usage. No, I can't do that. I can't do that. So yeah, so Rajat has given me the definition. Thank you, Rajat. I'll just read it out for everyone. And it's actually a very good definition, a very accurate one. Rajat says it's the amount of time to finish the job without delaying the next milestone or actual completion date. Right? I'll repeat it once. Please pay attention, everyone. And I want everyone to say thank you to Rajat for that. Rajat is saying it is the amount of time to time taken to finish the job without delaying the next milestone or actual completion date. Right? So does everyone know what is critical path now? Everyone is saying thanks to you, Rajat. Okay, great. So now, see, this is the beauty of having so many people in the class, because everyone can give us something. So Rajat has yeah, great. So now, as I told you, right, if one of these graphs end up becoming a critical path, see, first thing is, can you really split the data into equal parts? That's one challenge, right? Because you may not be able to split that. Now, if this is yearly information also, it is possible that in some years there are more records, in some years there are lesser records, right? And it is very difficult to actually split that. Does everyone understand that? Does everyone agree with that fact? So, and even if we split them equally, then the next challenge is the critical path problem, right? So two problems we understood. First is splitting in equal proportions may not be the best way to handle this, because sometimes same data which we would have actually easily managed, it was in the same split, would have gone into the next split, and it would have led to a problem. I'll show you this example of this later on, okay, where this could be a problem, okay. But on a higher level, you've understood what I'm trying to say, everyone? What I'm trying to say is, it may not, sometimes it may be best to keep related data in the same split, right? So if I'm actually looking at a yearly distribution of something, and in 1 year the number of values are more, and I want to just figure out what is the maximum in that year, it may be a good idea to actually put it in the same split. Instead of splitting 1 year's value here and putting it across in this, if you have 2 year values, right, then what I get is not the yearly max, but the max of the split, right? Is that clear to everyone? If whatever monologue I just gave on the equal split thing? Anyone who is not clear, I'll explain it again. Great. So I'm getting a lot of smileys today. Thank you very much, guys. Clear, the bunkers is clear. Great. So yeah, keep on sending smileys if you're able to understand this. If there is anything which you're not able to understand, feel free to stop me. Okay, great. Thanks, Parthavan. Thank you very much. Okay, so now one challenge which we've understood is that dividing them into equal splits may not be the best idea. And if we do not divide them into equal splits, then we will surely get into this critical path problem. That's also clear to everyone. But even if we divide them into equal parts, then also we might get into, look at the usage of the thing, we will surely get into a critical path problem when we do non-equal splits. Is that correct, everyone? And if we do equal splits, we might get into a critical path problem here. Is this sentence clear to everyone? Or has it gone over your head? Okay, got a lot of smileys, so I agree, I understand it is clear. Okay. Now, anyone in the class, Tushar, Shriram, who are not in the last class, if for some reason you're not able to follow, right, please do not hesitate in asking. All of our batchmates have agreed that I take a little longer to teach something, so they have agreed, and they have said that it is fine. They are okay to wait a little long. So please make sure that don't hesitate to ask. Okay, thank you, Shriram. Okay, and thank you everyone else. Vinod, you are still with us. It's not too late for you, not sleeping anymore till now. Okay, so now these two things, okay, great. So two things which we understood. One was that splitting is the natural way of doing things, but the challenges with splitting could be that splitting equally has its own challenge, non-splitting equally has its own challenges, right? And then you do a CAT. Okay, now these are the two very important things. The second, the more important thing, then another important thing comes in the reliability. One of the machine may fail, right? How will you make sure that the reliability thing is taken care of, right? That's another challenge, right? Isn't it, guys? Smiley, quickly, if you agree to that. If one of the job fails, then probably, thanks Sachi, thank you very much. So if one of the job fails, then you have a lot of trouble, right? You don't know whether you got the right answer or not. Right? Because if you are looking at the maximum temperature in a century and the machine on which the hottest year was there failed, then you get inaccurate results, right? True or not? So reliability plays a very, very important role here, right? So that's very important. Thank you very much for be interactive in the class. I'm sure everyone will understand at the end of it. Okay. Now, so that's very important thing. Now, failed jobs, who's going to handle, right? Now, tell me, these are all running in a different machine. Who is going to run the overall job? Someone has to run this overall job also, right? Which Dilip would have written in his script that split this, do grabs are done here, then do this cat and then final result, right? So no, Rajat, let's not get to job tracker. Okay, let's not. We are not talking about Hadoop. We have not reached Hadoop till now. Okay, let's try to understand who is going to do that overall job here, right? So that's one challenge, isn't it, guys? So the challenges which we have are quickly. Can you quickly write it down on the chat window? What all challenges I talked about till now? I'll also repeat it once again because that's all. Those are the things which are important to understand. Reliability, one. Splitting the file, very nice. Unequal split has its own challenge. Right, master job, very nice. Reliability, if one machine is down, very nice. Okay, one more thing, critical path. Incorrect results due to failure, right. Very nice. So these are the challenges, right. Now theoretically and practically also, this is all possible, right. You can write a very good framework, which I'm sure a lot of you who are hardcore programmers and I'll probably say Avinash and Ravi, I'll just pick these names, or Dilip, because they've told me that they are hardcore programmers. Scalability also is a challenge, right? Dilip tells me, right? Who have done a lot of programming in Unix. They will claim that if a company gives them this job, they will be able to do it. Okay. So yeah. So Ravi, I will agree when you send me this awk program by the end of this class. Okay. Okay. I'm just being a little early in the press, but I want you to send the awk program. Okay. Yeah. Okay. Thank you. No, not at all, Ravi. Not at all, man. Not at all sarcastic. I'm just, I know you guys last time also I had a class with you. I learned from you guys as well. So definitely you've shown me that promise. So please, so yeah. So coming back to the fact that these are the challenges which we have. Now, any great programmer or any great guy who claims that, I mean, not even claims, I mean, a lot of you people have been from the software background. I'm sure a lot of you will be able to create such a program, right? How many people think they'll be able to create such a program which can take care of this? Avinash says yes. Rajat also says yes. Rajat, I will come to that. Okay, Rajat Behra. There are two Rajats in the class, so please don't get confused. I will call Rajat Rastogi as Rastogi and Rajat Behra as Behra. Is that fine with both of you? Yeah. Okay. So Behra is asking me a question. Just confirm my understanding on responsibility challenge. Who will be doing what and when? Okay, Rajat, I will. That is not a very good question to ask at this point of time. Very soon we'll come to know that. Okay, but I'll quickly answer that. So there will be one overall job which will be managing all these things, splitting and then pushing these jobs on different machines and then doing a final cat and showing it. That's the overall responsibility of someone who has to do it. Then these machines have to do this grep. Someone has to do this cat, right? So we have, these are the kind of problems which we'll have. These are the things sure. So Ravi says difficult, not sure. Okay. Sync sort is what, okay, sync and sort, right. Okay. So with JCL and COBOL, Dipankar will be able to do that. Okay. Now, how many people think they'll not be able to do that? Time taking is what Ashish says. Great. So there will be a sorting also involved, right? Very nice. So I think by the time I reach MapReduce, right, you would have actually told me that. No, I'm not saying at this point of time. If I give you 2 days time to write something like this, so through ab initio I can do that, says Orca. Okay. So if I give you 7 days time, can you write this program and give it back to me, which can take care of all the reliability issues as well? Sriram says I can create a OLAP cube and get it done. Okay. Okay. So I'm sure some of the people can do it, some people cannot do it. They want to use different technologies for doing it. it is impossible to determine the failures not speaking to each other, right? So it's, yes, it is very difficult, right, Ravi? That's true. So now who does, so you know why do we need something else? Now everyone understands. God gave Hadoop, why use stairs when you have a lift? Wow. Yeah, so Ravi says God gave Hadoop, why use stairs when you have a lift? Right. So very nice. Thank you very much. Thank you very much, Ravi, for that great piece of poetry is what I'll call it. I'm not very good at English, so please, wisdom is what Dipankar says, right? So that is a wisdom nugget from Ravi. Okay, my friend who is lift. Okay, so Vamsi is saying lift can stop in case of power failure. When we are over, what do we need to? Okay, so Ramesh is telling when we are over with, then we need to use stairs sometime. Okay, use stairs in case of emergency. That's why I'm telling you guys, learn awk. Okay. So not Hadoop is going to come to your rescue every time. Not every time when you are given a job, the data set will so use that you will tell your management that I'll use Hadoop to do it. Okay, they'll throw you out. What you will get in response is a pink slip. If you tell them that I want to look at these logs and use Hadoop to do this. Okay, so you should, all of you should actually learn awk then. Awk comes very handy. Very few people know them. You can also boast that you know awk in your office. Okay, so definitely learn awk. Okay. Now that we have established the fact that there are some challenges with the traditional way, and we have also looked at them, that processing capacity of each machine, splitting the jobs, the critical path problem, reliability, failed jobs, who runs the overall job. These are the challenges, and so we got a lift then, right? And the stairs could be awk, but we got a lift, as Ravi says. That's where our way of doing things, the MapReduce way of doing things, helps, right? So Dipankar, are you clear? Why do we need MapReduce now? Let's not go to MapReduce is a key value pair of programming, which will be used to do this some definition, and then you become some XYZ certified Hadoop developer. Don't just rely on that. Okay. So it's very important to know where to use it and where not to use it. Okay. So now can you tell me, if the data set is small and if the files are small, okay, let me ask that question later. Okay, not the right time to ask that question as well. I'll ask you that question by the end of this class. Okay, if I don't ask you this question, please remind me that you had to ask some question on file sizes. I'll ask you that and make that clear then. Okay, so let's move ahead and let's see. Now I have introduced the term MapReduce on this file, but I'll not talk about MapReduce still. Okay. I want to actually understand from all of you that I want to see what are the characteristics of such data. Okay, so before now these are some equations which are written here. How many people by looking at this slide can understand what I'm talking about? Just tell me yes or no. Avinash says he understands. Rahul says no. Anyone who understands yes, just tell me yes. No, I know. I mean, you will not understand. That's why you are here, right? Sachi says 50%. Okay. Key value, I understood. Hash map, hash table, says Vinod. Parthivan says no. So anyone who doesn't understand, no need to write anything. Vamsi says functional programming. Okay. Key value is the key for MapReduce. Okay. Ashish says functional programming there. Okay. Now guys, one thing which is very clear from the data set which we saw, and it will become much more clearer as we see more data sets, that what we were looking at are key values. Okay, right? Where key is the year and temperature is the value. And we need a programming model which can handle this very well, right? So that programming model is called MapReduce. But before we get to those terms, jargon, map and reduce, don't have to worry about that. Let me tell you what do we need to do first. Now the first thing which we need to do is extract key values from that data which we had, right? And create key values, which means that if some year comes, some temperature comes, year temperature, that year may come multiple times, the temperature may come multiple times. So remove all the things which do not form, which are not required from that data, come up with a key value pairs, right? Which is a key and a value pair, right here, K1, V1, right? Do not worry if these equations are not making things very clear to you. I'll just show you an example as well. Let's try to understand with the equation and then we'll go to the example. right? Now, next thing which we need to do is actually do a sort. Yes, we will, Vamsi, we'll go to that. We will exactly, yes, key is always unique in nature. Now, let me tell you how we're going to proceed with this class. Okay. Now, right now we'll see this. Then we will go back to our example, which we saw. We'll write a program, a MapReduce program to actually take out those things which we talked about. Okay. Okay. So is that clear, guys? So just give me 1 second. I want you to actually look at this. I'll explain what is this list K2V2, what is this K2 and list V2, and what is list K3V3. Okay. So these are the 4 steps which we have, and I will just explain it. I want you to actually just keep this in your mind. Okay. Okay. So now let's look at that example once again, and then I'll show you what are we actually going to do here, and how we'll come back to this slide once again. Okay. For now, you can understand that initially what we do from that data is extract key and value pairs. So these will be these key and value pairs. Then what we're going to do is we are going to create a list, okay, which will have the key and the value list, okay, which will show me that for each key, if there is a repetition of that value, we'll get those values here. So that's what we're going to do next. Okay. Then we are basically based on sorting and grouping them together. Okay. Now next thing which you're going to do is we will use a function which will do the actual thing which we want to do. If you want to do a max, if you want to do a sum, and those things we will do, and then finally we'll come up with again a key value pair. Okay. So now this is some. Okay, Dipankar is asking question, list K2V2, grouping is from key within map. Yes. So now, okay, now Dipankar, that's a question which I'm not going to answer now. I'm just trying to confuse everyone right now. Okay. So that they have this thing in their mind, because this is something which they'll have to see all the time. I want them to become familiar with this term. So this is how it will be written in every book. I'll explain with an example. So within 15-20 minutes, this will become crystal clear. Okay. Sometimes it is good to have chaos. Okay. So now I'll repeat this once again. What I'm saying here is that initially we'll extract key and value pairs, okay, from the list. Key and value pairs. Okay. Just understand these are key and value pairs. Now we are going to create a list, a key and a list of values out of that. So key and a list of values will be created out of that. Okay. Now this will be done obviously by doing some kind of sorting and grouping from this key value pairs. Okay, so that's the second thing which we do. Then we use this list, which was the key and a value list, and do some. Just a minute, Vamsi. It will be clear. Okay, and then do some manipulation or some calculation on this thing to get another key value pairs. Okay. Now, when I'm saying all this, I know it is not clear to anyone. Okay. But I still want you to remember these terms. Now, as we move on to the next slides and as we look at the examples, it will become very clear. Okay. So let's move on. No need to stop here. Ashish, all those things will be answered here. Okay. Yes. So Sriram is saying, so say I have this question I'm going to answer. Sriram is saying I have a location in each file and temperature for day in each file. Key is location and temperature is value. Right. That can be one of the key value. Right. That's right. So this level of questions I am going to answer. I am not going to answer output of map and input of reduce is different. I am not going to answer this question list K2V2 grouping for a key within a mapper output. So all these questions I am going to answer a little later. Okay, Dipankar and Vamsi and Ashish, just give me some time. Okay. How it's going to split in this case is also something which I'm just going to tell you, Ashish. Okay, just give me 2 minutes. Okay, let's move ahead. And there is one, you'll very soon understand why I have created all this confusion in your minds. Okay, so very important to create chaos first and then figure out if it is clear or not, right? Otherwise it will become very simple and you will go back thinking that you have learned everything. Okay, I don't want you to do that. Okay. Let's take this example. Now it will become very clear. Okay. So look at this example, guys. This is your input. Now you remember I put this key value here, right? So this is the splitting. Okay. So you've created all these, you have split those records as deer, beer, river, car, river, deer, car, river, bear. Okay. Then what you do, in this you say deer comes once, bear come once, river come once. Okay, so this is that list with the mapping which we are talking about. Don't worry about these terms which are there at the top. You will these shuffling, reducing, finalizing, all these things, terminology will become very clear very soon. Okay. Now what we do here is, okay, so Raghu, Hadoop will do it. Hadoop will do the splitting. Okay. You can configure how big split and all those things are possible, but Hadoop will do the splitting. Now, okay, so now does everyone understand this part? Till now everyone is clear what I'm talking about? This list K2, V2 is clear to everyone? First we created these key values here, K1, V1 values. Yes. Yes, Avinash. Okay, yeah, so now, okay, so Rajat is asking me why everywhere value is 1. Okay, it is 1 because in this case, in this particular record, deer came once, bear came once, river came once. If it was like deer, bear and river, okay, then it will be twice here. Is that clear, guys? No, it will, yeah, so it will come twice, but not, number 2 will not come here. Okay, it will come like deer 1, another deer 1, something like this. You look at this one, right? This example, can you see? Yes. Car is coming twice. Yes. So this is how it will be done. There is no calculation happening here. Yeah, like car. Okay. Now the first thing which you do is you just thanks Ravi. Thanks. Ravi says very concise diagram and clear diagram. Honestly, very good. Okay. Yeah, Dhananjay, just wait on. Wait for some time. Okay. Wait for some time. All these things will become very. I have not reached that stage till now. Okay. Now, this is the key. This is the value. Right. So what we have done till now. Okay. What we have done till now is that deer is the key. 1 is the value. Bear is the key. 1 is the value. River is the key. 1 is the value. In this record, car is the key, 1 is the value. Another time car comes, I write once again. Okay, right? And then we write deer, car, bear as values here. Okay. Now what we do? We do some, now one thing which is important to do is, it will be good if we could do some shuffling and get these things like this. So wherever bear is coming, we'll take all those records and put them together. Okay, that's called shuffling. Okay. Obviously, you'll call it shuffling only, okay, and you'll group them together, okay. So you'll have, now what you have is, you have bear and that comes 1, 1. You can look at it this way also. You can also write this as, let me just open a notepad. Some people who already know MapReduce will ask me, why are you not writing it in the traditional way? So let me just quickly open notepad and show you how it can also be represented. So it can also be represented as, okay, forgive me for these parentheses and brackets, okay, I'm just taking a liberty here, okay. So this part which is written here can also be represented as this, okay. So this is grouping of similar items together and putting a value for those, exactly. Right? So that's what Vamsi has told me. This is what we'll probably end up doing at this stage. Okay, is that clear, guys? Yes, Rajat, Hadoop does this for you. Okay, I have not yet reached Hadoop. Okay, so guys, I have not yet reached Hadoop. So please do not ask me questions on Hadoop till now. Okay, I'm just telling you a process which is slightly different than the earlier process. Okay, which we used, right? And then we'll see how Hadoop is doing that. Okay, Rajat, is that fine with you? Rajat, I mean Rajat Rastogi. Okay, great. So now this is what we'll get on this point. Okay, so for car, now Sachi is asking me a good question. I will write for car. So for car, I'll write like this. Okay, is that clear now? Everyone? Okay, for deer it will be same as deer. So any number of, so this is the thing which we talked about when we were on the last slide. Let me go back to the last slide and see if things are, the thing which was looking very difficult, mathematical kind of equation where I confused you, whether it is looking better now or not. Okay. Shall I go back to the last slide? Guys, if you don't mind, and I'll come back to this one once again. Let's see if we've understood something on the lab. Ashish, I'll not answer that question right now. Okay. Ashish is asking, why have we not done reducing in the mapping phase? Does anyone want to know this answer now? Other than Ashish? Okay, everyone is saying no. And some people are giving you a big no also, Ashish. Okay, so just, unfortunately, this is a group of people. Okay, so I'll have to respect. Okay. Yeah. So don't worry, Ashish, but I assure you this will be answered today only. Okay. Is that fine, Ashish? Not now. I have not got an answer from Ashish on that. Okay. Thanks. Ashish has given me a smiley. So thank you guys. And you have all the right to stop me from diverting from the topic. Okay. Okay. Now we have a lot of questions. Let me read through those questions and I'll see whatever I want to answer now. Okay. So Dipankar says because value of same key may be in different split. Right. That's very much possible and that's why we have done this shuffling here. Right. No, don't worry about Java list or not. This is not a Java list. This is just a representation here, Ramesh, where we say that this is a list of K2 and V2. So here is the list, right? K2 and V2 are the, so Ramesh is asking me, I did not understand list K2, V2, which means he did not understand. Now these are key values. That is clear to everyone. This is a list of key values. This is also clear to everyone, right? Right? And if I represent this part as what I showed on notepad, then this is a key and a list, isn't it? Is that clear to everyone? Yeah, sorry, Vamsi, actually it is written as bear and I pronounce it as beer because that's what I like better. Okay, so Vamsi is asking me, he's trying to pull my leg as well. He's trying to ask me, is it a beer or a bear? So it's a bear, but I like beer better. So okay, okay, okay. Now let me explain you what are these terms. Okay. Now everyone knows that this part which I have written here is a key and a value. These are key and values, right? These are simple values. There is no list associated here, right? This is just a record, which is there's no list. Everyone, yes or no? Quickly. Okay. Great. Now let's come to this. Now is this a list? Vamsi, you can represent anything as key and anything as value. I don't mind that. Okay. Okay, you can say anything as key, anything as value. These are, if this is a key, these can be values also. Who knows, right? It's only after doing something which we'll come to know. But right now, look at it as a single record which has some values. Okay. Now this is a list. Everyone understands that, which has key and a value. Yes, from that context, Vamsi, that was not a key and value pair, right? Fine. But this is a list. Everyone agrees when I say list of key and values, right? So deer, bear, river, beer. Right? Right? So this is a list. Everyone agrees to that. Now, when I say that this is a key and a list of values, this picture may not represent that very well. Right? So that's why I've written this. So this is where I say K2 and list V2. Is that clear? Everyone has got it now? The reason why I opened notepad, I could have done it here also. Great, right? So this is a list V2 now. Great. So everyone is saying more clear now. Thank you, Rajat. Okay, Dilip is also giving me a smiley. I think even in the slides also it can be represented as, yes, it can be, but it can be represented there, but what happens is then people will not understand this process of shuffling, right? So there can be one more thing, then it will add, some people will ask me what is this process called. Okay, so in the slide I think this is okay because we want to actually put them together, right? And I will use this notepad to tell you that how is this a list value. Yes, Tushar, what you are saying is right. It's not really a list. No, Tushar, what you are saying is not right because this is not really a list. Now it is, when I write it this way, it is not a list, right? This is one part, this is another part, okay, and say a river, and don't quote me whether I'm using the correct values or not. So if river comes here, then this is another part. So basically this is not, now Tushar is asking me, is this a list? This is what Tushar is asking me. Okay. Thanks. Parthavan says awesome explanation for MapReduce process. Okay. So before Parthavan, thank you very much. I really appreciate your words here, but just give me 5 minutes. I want to make sure that everyone has understood it, right? So great. So now this is not really this because this list will not be there. These will be only this part. Okay. So we'll have these as separate things. Okay. Now, when we get to the next process, what we wanted to do? We wanted to do how many bears were there. Okay. Now, I also wanted to count how many cars were there. Okay. So what I do, I'll take this part, okay, and use a transformation here. That transformation could be key some function on this value list. Right? Is that clear to everyone, guys? So now this function could be a max function, this function could be a summation function or whatever. This is the process where I'll do the actual work, right? Okay, and this is where I'll find, if this is summation, then I'll find out this here. Okay, is that clear, guys? Everyone is clear up to this point? This function which I've highlighted here. Can I get a round of smileys if everyone is happy with this explanation? Okay, great. Is there anyone who has not understood it? Because see, I'll tell you one thing, there will be many people who would have actually looked at MapReduce, they would have looked at YouTube videos, they would have tried everything, still they would not be very clear. So I want you to be very clear about after this class. Everyone should be very clear about this, right? Yes, in this context, Tushar, it is sum. The function is sum. It could be max, it could be anything. I mean, you may write any function on earth here which can do something with this value list. Okay. And finally create what? Out of this function value list, what will you get? You'll get again a key and a value. Right? If it is a max, you will get the max value here. If it is a sum, you will get the sum. If it is a mean, you will get the mean. Right? Is it clear, everyone? So this will be the output of this process. Okay. And then finally, what we're going to do is create this, which will be the list. This will be the final list. This will be a list of these K3s and V3s, right? So this is K3 and V3, right? So let me write those numbers here, K3 and V3. And let me write this K2 and list V2 so that everything becomes very clear to everyone. And let me write just before this where we started. So we started with what? We started with K1, V1. Then we went on to create a list of K2, V2, right? Then we went on to create K2 and list of V2, and then we wrote a function here. Finally we got this, and then we got a list K3 V3. Is this process clear to everyone? Anyone in this class who is not very clear about this process, quickly tell me. If everyone is clear, I can get a quick round of smileys for this. Pankar, you were telling me. Okay. Okay. So Sachi is telling me, let me fill gasoline for your Lamborghini. Buy a smiley. Thanks, Sachi. Thank you very much. I hope that Edureka gives me enough money to buy a Maruti 800. I don't dream about Lamborghini. Okay. Yeah. I'm a very poor guy. I was a failure in college and I'm a failure still in my life. Okay. And old as well. So Lamborghini is something which I don't dream anymore. Okay. Great. So thank you very much. Okay. So Dipankar is saying I will contribute. Okay, so Vamsi is telling me, then you are the next guy like Siri Johnson. Don't do that, Vamsi, to me, man. Okay, so guys, okay, now let's come back to this. Thanks for all the comments. Okay, I have already contributed by paying my fee. Thank you very much. I am really thankful to Avinash for paying that huge amount of fees which you have paid for this class. Okay, my children will be really thankful to you throughout their ages, because this is just because of your fees that they'll get some roti today. Okay. Thank you very much. Thank you very much to everyone who has paid fees for this class. Okay. And I hope that Edureka pays me a part of that. Okay. But yeah, coming back to this. Now everyone has understood this part. Okay. Yes, I'm getting a lot of yeses now. Let's go back to the previous slide where all of you got confused. Yeah. So is it making sense now, guys? Whatever I showed you here? Quickly, yes. Everyone has understood what is MapReduce? Okay. So everyone is saying this slide is clear now. So now, do you think it was a good idea to create that chaos in your mind then? To make sure that you don't understand anything and then you understand? Avinash? Okay. Any formal definition, can you put in one line any formal definition? I know you don't like definitions, chaos theory, pattern in randomness. I'll let my friend Rajat Behra, who is a PMP, give me a definition for this. I don't know any definition here. So, frankly speaking, I have never understood these definitions. So I'll not be able to give you a definition. I've explained it to you, right? Why do you need a definition? If someone asks you in an interview, define MapReduce, tell them that I'm not going to define it. I'll going to show you what it is. Ask them the definition. Okay, no one is going to define you that. Vamsi, don't worry. I will send you. No, I know. So in the interview you can explain this. I'll send you a formal definition also. Okay. I know. In interviews you will be asked such crap questions. Define MapReduce. Okay. Okay, so Rajat is giving me the answer, combination of two words, map and reduce. Okay, yeah, that's the PMP definition of a manager for MapReduce, and that's really true, right? I mean, it's a combination of map and reduce. Okay, now what is map and what reduce? Get to the definition there. Then they'll ask you what. Okay, Dilip has given very good. Dilip, my friend, has helped you. You should say thanks to Dilip and you can be angry at me. Dilip said it's a programming model and process for processing large data sets on cluster computers. Great, clusters of computers. Dipankar says determining logical unit of data, grouping them together and performing some operation on it. Okay, guys, is that clear? Is this Dipankar? Let's go back to our example slide and see, is this what we were doing? Thank you, Dipankar, for that definition. So Dipankar says, Vamsi, you can note down this definition. Okay, I can also copy and paste and send it to you. Okay, determining logical unit of data, grouping them together and performing some operation on it. That is map and reduce in probably 3 sentences with 2 conjunctions. Okay, and a comma. Okay, and finally 2 dots after it. Okay, so that's the definition. Okay, so is this what we are doing? Determining logical units of data, grouping them together here, and then performing some function operation here, right? Thank you, Dipankar. Rahul is telling, I will remember this only by car, river and bear, and hopefully with beer as well. Ramesh Chaudhary is saying, it remembers me of Three Idiot movie where Amir Khan is asking about definition in class. Yeah, definition in class is very difficult one. Someone came to our rescue. Dipankar is laughing. Okay. I will remember my beer is what Avinash is telling me. Dipankar is, okay. So guys, now everyone understands. I know, see, I'll tell you one thing. None of us have come here to study. We have come here to get entertained. Okay. So whenever I get to studies, you start talking about beer and Katrina and all these things. And then people blame me that you are, okay. Yeah, Vinay, that's what I'm saying here. Vinay, I'm really sorry about that. Okay. Let's come. Now we understand this. Okay. Vinay, I'm really sorry about that. I don't want to get into all this right now. So let's come back to the point. And Vinay is telling me, please come to the point and don't waste my time. Okay. So yes, Vinay, I'm really sorry about that. So let's get back to the work. So now we have understood this MapReduce. Vinay has given me a smiley, so he was not all that angry. He was probably telling you guys that come to the point, and he was agreeing with me because I was also telling the same thing. Okay. So Vamsi is telling, but honestly, I wanted the definition to tell my mind about the whole process in one-liner. So I'll repeat that that definition once again, and you should say thanks to our friend Dipankar about it. Okay, where he said, I don't remember that. Okay. Determining logical unit of data, grouping them together and performing some operation on it. Dipankar Vishwas. Okay. So Rajat has given me another definition. And Vamsi is saying thank you to Dipankar. Rajat is saying MapReduce is a programming model that's well suits for data set where only one write and multiple read and to pass data to arrive at same conclusion. Very good, Rajat. I think that's a very good definition. And the reason why I say that a very good definition, because that's where we started with in our first class, that this is for streaming data access, which means you write it once and you have to read things and parse them multiple times to arrive, right? Great. So thank you very much, guys. So now I think all of us are contributing well here. Vinay, I am sure you like these two definitions, and this makes the whole process much clearer, right? And you don't think that we have wasted a lot of time. We've just reached 1.5 hours, well, out of which we have had fun for half an hour. Okay, so not too bad, right? Okay. Okay, so let's go. Okay, thank you, Vinay. Thank you for the smileys. So now everyone knows what MapReduce is. Anyone in the class or in the world who doesn't know MapReduce? Everyone understands what MapReducing is? Okay, great. Let us go and see in, great. So I am getting a lot of smileys here. So let's now you'll ask me, show me in practical, right? So let me show it to you in, yes, it is Vinay like that. Okay, but let's not do that comparison here because that's not the right point to do that comparison. We'll compare that when we move further in our classes. We'll not leave MapReduce now. Okay, so let's go and look at things. How do they look like in a program? Now, though I promised you that I'll be using Hadoop streaming as well and show you in various languages, let me get started with some Java. Okay, now everyone knows Eclipse. Let me show the same thing happening in Java. Okay, everyone knows Eclipse. This is a familiar thing to everyone. Okay, you want me to match the window. What I'll try to do is I'll probably increase the font size here so that it becomes much more clearer, right? Just give me 1 second. I'll try to do that. Which version of Eclipse are you using? Is the question Avinash is asking me. Avinash, I don't know, yaar. There is some version which works well, so I use that one. But don't worry, I'll tell you. I'll tell you, Avinash. Just give me one. I'll tell you which version. I know how to find the version. Okay. Let me just try to find out if I can figure out a way to increase the font size. I am not able to find that. Anyone tell me, oh, go to editor is what my friend is telling me. Windows. Okay, Avinash, what next? Preference. Yeah, go down. I need to go down, right? There is a, no, wait. Let me just do that. Preference. Okay. I think it should be in general. Preferences Java is what Avinash is telling me. Okay. Then what? Editor. Okay. Where do I find the option to increase the font size? Syntax coloring. General text editor. Okay. Windows preference general. Yeah, that's what I thought. Text edit. It should be in general editor. Go to text editor. Okay. Great. So Praveen, I am there. Now help me out. Okay, got it. So I think we can just increase it a little bit. Okay. So is this much better, guys? Everyone is able to see this? Great. Fine. So let me show you this. I mean now this program which we just saw is actually, Avinash, just a minute. I'll tell you which version are we using. Okay. Just give me one second. So this is the ADT Eclipse version. So this is the version, Avinash, here. Okay. I'll probably send you this. You can download the same version from. We will send. You can ask the support team. These people can give you. Okay. No, I don't think there's any reason. There's no reason why we are just using the Android one, because just to tell you that there is a very popular Android program which Edureka runs, and my friend here is telling me to publicize that a little bit, so I'll do that. So that's why they are using this Android version. Okay, there is a very popular Android program here, guys. So any one of you who wants to learn Android or have kids who want to learn Android, ask them to join Edureka's program. Okay, thank you. Thanks. That was a commercial break. Okay. Okay. So I'll send you this version if you want, Avinash. Okay. Now let's come to this. Now what we just saw was a word count program. Okay. What we just saw was a word count program. Okay. No, there is no extra. So there is some. Vamsi, I'll answer that question later. Okay. We are not talking about Eclipse right now. Okay. Okay, Dipankar, that also I'll show you. Wait. I'll tell you one thing what I'm going to do now. What I'm going to do now is I'll show you this program, explain you this program in Java, then I'll create a jar file out of this. Then I'm going to run this same program on Hadoop and show you how the MapReduce really runs. Okay, this is version. First thing which we do is we define a job conf. Okay. Now we call it. We define a new job configuration word count.class. Okay. You can set a name also. This is optional. Okay. Word count. Okay. No need to worry too much about here. Then you set the mapper class. Okay. Conf.set mapper class. Okay. So this is the class in which we set the mapper class. Mapper class is this map class which you've defined up here. Okay. This is the map which we're talking about. Okay. Now if you go down, we also define the reducer class here. Okay. Then we set the output key class. Okay. Now what will be the output type? When the output comes out, we know the output is a key and value pair, right? We know, everyone knows that. From the last slide we've seen that, guys. Is that correct? Or is it not? You don't remember that? I want answer from everyone, guys. Great. So yes, great. So now we know that the output, so here, this is where we define what will be the output type. Okay. The input types can be different, the output types can be different. Okay. Now in this program, since we have text as the output key, where it could be bear, dare, whatever, right? And int writable is a special type of int for Hadoop. Okay. And since it is an integer output, we will be using that, right? So Dilip, my friend, is trying to help me out. Thank you, Dilip. He's telling me here are the 4 basic parameters of mapper. Right. Long writable, text and int writable. So we'll talk about them a little bit, but let me explain you from a top level where we are looking at the black box, where we are just talking about what is the output and what is the input here. Okay, we'll go into it just now. Just in a while we'll go into it. Okay. So for now, understand that the output is a text. The key output is text type. The value output is int type. Okay. In this particular program which we just saw, where we are talking about bear, dare and whatever, right? Similarly, no, there is no reason why we have defined output before input. It doesn't matter. Avinash is asking why we have output before input. Okay, it can be in any order. All these can be in any order, right? There's no problem with that. Okay, is that fine? Now, finally, this is where we set the input types. Now, as I promised you right in the beginning of the class that I'll be discussing about different input types and different output types, input formats. Just assume that right now we are setting the text input format for this class, for the input format. Okay, the set output format is text output format. Okay. These are the default values. Okay. So don't worry about these are the default values. We'll look at more types when in the next class probably. Okay, where we'll talk about sequence and all those things which I mentioned in the slide first. Now this is very important, and this is one of the things which you should really look at. This is file input format that's .set input paths, conf and new path, which means this is the path from where I'll pick the input files, okay, on which I'll be doing the processing. Okay, and arg0, everyone knows what it means? Everyone knows that? Anyone who doesn't know that? Okay. So basically command line argument number 1 will be arg0. If you're passing command line argument, that's right. So arg0 will be the first argument which you pass along with that command. Okay, Gaurav, is that clear? And arg1 will be the second one. Okay, so when you run this program, you will say program name, then input file path and the output file path. Okay, that's how we are going to run this. Okay, if you remember last time we showed you a jar file and we showed how to run a program. From that, we will doing the same thing here also. Here these are the inputs and the outputs of that. Okay, we'll just do that as well. We'll show you this. Okay, for now let's try to understand this program. So this part is clear. Then finally we'll say this is the run job method. Okay, this is the run job method in the job tracker. Okay, this will tell the job tracker to run this command. Okay, now let's go up. We'll understand more of this. Let's look at this map class. And what is it doing? Is it doing really what we showed in the presentation just now? Okay, let's try to find that out. So basically we have, now this is when we say implements, which means this is what? This is a class or an interface? Whoever knows Java has to answer that answer. Give me that answer. Okay, great. So our class map, okay, extends an interface, okay, extends a base class and implements a mapper interface, right? Is that clear, guys? So this is the web class and this is the interface, right? Everyone is clear with this? This much Java everyone knows? Exactly. Extends query class and to implement method in mapper interface. Exactly. Okay, just a second. Is my voice not clear to everyone? There are some people who are saying voice is not clear. Great, great Dipankar. Okay, fine. Thank you. So is this clear to everyone now? Right, what we are doing here? This is our class which extends this class and implements a method mapper from the interface. Okay? So that is how, and these are generic inputs, generic types. Okay. Now when we come to this, we talk about a method map, okay, which we are overriding, right? We are overriding a method map, okay, and defining it here, right? So we have inputs, long writable key, text value, these are the inputs, and there is an output collector which is text and int writable from the map. And reporter is basically If you remember, when we run a MapReduce program, it tells us that 0% done, 2% done, that reporting which happens on the command line, right? On the screen. We will show you that as well. Do you remember that what happens when we run a MapReduce program? It shows on the screen that, okay, 0% done, 10% done, reduced process done. Remember that? Okay, Rajat. Let me explain. Let me explain that once. So these are the input types. This is the output collector. Okay. And reporter is the thing where we actually report what is happening. Okay. Yeah, it is a progress updater. Exactly, Rajat. Rajat has given me that answer. Thank you. Great. So is this clear, everyone, guys? And it throws a IO exception. Now, throws. Everyone knows what throws is. Whenever it finds the IO exception, it will throw a. Whenever it is not able to find that input file, it will throw a IO exception, saying that file not found or something. Okay. Is that clear, guys? Everyone? Very simple till now. Quickly a yes and or a smiley. Very quickly. I want a yes from everyone. Great. Very nice. Very nice. Now, what we're doing here is we're saying a string, line, value, to string. Okay. So basically, if this is my complete line, okay, it will go in this. You convert this value into string using this. Okay. This is my complete value, and I will convert it into a line using toString method. Okay, is that clear, guys? So this, let's see. I'm fine. I've written twice. Okay, great. Now, string tokenizer, we create a tokenizer out of it. Okay. Now, when we tokenizer means it will split these values. Okay. On what? Can someone tell me that? Avinash has sent me something. Okay. Okay, great. So Avinash has sent an example for everyone. Great. Let me just pick that example. On a delimiter, unless till the end of line, Rajat is telling me, very nice. The default delimiter is space, each word. Okay. So I've got my answers here. Okay. So string tokenizer, this is test. Okay. Very nice. So Avinash has given me an output which I'll copy and paste. I'll try to do that. Okay. And I really like this way of learning, guys. Everyone is contributing. I really like that. Okay. So now, for people who are not very familiar with Java, Gaurav and all who have not been able to do a lot of practice, this is what Avinash has sent us. And I'm sending that to you. Okay, very good. So everyone has got this here, where he has written a quick program which says string tokenizer, st, new string tokenizer. This is a test, is the complete string. While it has more tokens, println. Println will print in the next token. So it has clearly told you that this is a test, has been splitted into 4 parts on the delimiter space by default, and every delimiter has been printed here. Okay, so this is a test will come one by one. Is that clear to everyone, guys? Let's give a quick round of smiley to our friend Avinash. Okay. Dipankar has given me said good one. Okay, thank you, Avinash. Thank you, everyone. A lot of people are saying thanks to Avinash. So now we have learned this part. Okay, smiley for Avinash is what Shriram is saying. Okay, okay. So Avinash gracefully accepted all the thanks. Okay, very rarely does that. Okay, but okay. So Avinash, just pulling your leg, man. You are my friend. Okay, so okay. Now looking at this, now that Avinash has told us everything, we know what is happening here, right? So let me show you what is happening. So if we had this value, right, that I am fine, okay, so this is the value, sorry, this is the value. Okay, so I1 am 1, like we saw in the last example, very similar to that. This will be the output of this. Is this clear to everyone, guys? What is happening here? So what you're doing is, whenever you get a value, you say new value will be assigned a value, new int writable, output dot collect. Okay, value and new int writable. So this is what is going to make something like this. Whenever you find a new token, in this I is a token, am is a token, fine is a token, then again I is a token, am is a token, fine is a token. Every time you find a new token, you print new iterable 1 along with it. Okay, is that clear to everyone, even to the folks who do not know Java? Ravi, are you still with us? Vinod, are you still with us? Great. Great. Okay. So the guys from the EST time zone, I know it's a little late, but we'll quickly be able to finish this off. Okay, great. So now this is what we'll get as output. Okay, is that clear? Now let's go to the, so this is what will finally happen as I told you. This will be done automatically by Hadoop itself. Okay. So this will be converted into I11 like we saw in the presentation, right? Is that clear, guys? Something like this is going to happen. I11, AM11, find11. This will be the thing. Okay. Keep on writing yes if you have understood it. If you've not, then keep on writing no. Okay. Great. Let's go to this. Okay. Now and see what is this reduce thing doing. Okay. Now the reducer input is again the same thing. The text, which is I, and iterable. Okay. Now look at this. The input to the So this is what we outputted from here. The same thing goes as a input to our reducer function, right? And finally the output will be text and iterable. Okay. Now if you look at this method, what we have here is text, which is a key, and then there is something called iterator. What is an iterator, guys? Quickly. What do we need here? List, right? No, it is, okay. So it's a list. List of values is what Vamsi tells me. Oh, iterate over the list. Very good. So iterator will iterate over the list. So as we saw, right, this is the input which we'll be getting here. So as we saw initially K and list V2, you remember that thing which we did? Where this is the thing which we had, right? So this is where we use the iterator thing, right? Is this clear to everyone, guys? The relationship between this part, this mathematical equation, and whatever we are doing in Java here, quickly? Yes? Good. Very nice. Very nice. Okay. Now, then we go here and say IO exception, throws IO exception again. Again, text and iterable are the outputs, and reporter, same things we saw. Now what we do, since we had to do a sum and tell you how many times does beer comes and how many times does bear comes and how many times does car come, what we have to do is, on this values, this was the iterator, has next tells me if it has a next value. Okay, it will come false when we reach the end of the list. Okay guys, everyone who's new to Java, this is how it works. Okay, what you do is sum plus value next. So the value of the next, you will get it here. Okay, so this will take you to the values next, and this will give you the value which is there in the next. Okay, so the value here will be 1, right? Every time on this list, sum is equal to sum plus 1. So every time you go through this loop, you will come up with one addition into it. If this was the input, then it will come with 1 first, then it will come with 2. Finally, when we get out of this loop, when we have finished this list, it will come with something like bear 3. Bear 3. Is this clear to everyone? What is happening here? Quickly, yes or no? So now if this is clear, then you've understood the MapReduce in Java as well. Okay. Now let's look at our original program. If we've understood everything here, yeah. Ravi, I'll answer that later on. Okay, it's a old API. Okay, it's a deprecated API. Okay. Now where is the flow of sorting of data take place? Okay. So this takes place. Okay, so we will also be looking at there are some more steps which happen. There is a very simplistic program. It's the shuffling steps itself. Okay, yes. In the shuffling step itself, the sorting also happens, and we will be looking at the other things also, partitioner and combiner, which we'll look in the next class. Okay, let's not go into that. I'll also tell you where we need it and what are the limitations with this program. This is a very simplistic program. Okay, guys? Is that clear? This is clear to everyone? Now, what I'm going to do next is, great. Can I quickly get a round of smileys from everyone? Now, till now, within this 1.5 hours, what you've understood is traditional way of doing things. Then you understood what is MapReduce. You also understood how to write a MapReduce program in Java, right? Isn't it great? Right. So now let's see how do we actually run it in a cluster, right? So before that, let's go to our weather data. Okay. Let me show you the same program which we saw the initial data which we saw. You remember that the first data set which we took out, which was looking something like this. You remember that, guys? I don't have to explain these things. I'll go down into this program. I'll quickly go down into this program and show you the same things which we saw earlier as well. Okay, there's one difference though. Same thing, create a set job name. Now here I've put a quick note for you. There the class was different, right? Set output map class was different. These are not default here, so we have to define them. Okay, so these properties had to be defined. Earlier it was not defined at all, right? So these are the two new things which have come up in this program. I want you to look at these things when we get out of the class. I'll be sending you both these programs. Default input types, there was what? Text and iterable. You remember that? Yes, Vamsi. Now in this case, the output is what? You have to give me a text only, right? What is the maximum temperature there, right? Whether it is, I will tell you what we're going to do with this. So that's why we had to redefine this, right? So that's the only difference. Other than that, there's no other difference. Everything remains same. Same way we define the input file path, output file path. Let's go quickly to our map function and see what we're trying to do in this. Okay. So in this, what we're trying to do here quickly is that again we do the same thing, value to string. We got everything in this line, right? So this becomes a string type, this complete thing. Now what is this doing? Line substring 614. Okay. This guy tells me where is the date. So date is here, right? So you pull out a substring out of this, and this is how you get the date value here. Is this clear to everyone? This line 36. What we're doing here, the line contains this whole thing, whole record, okay? And substring 6 to 14, this guy will contain your date, okay? Similarly, we'll get the minimum temperature and the maximum temperature and the minimum temperature. We store them into float. So what we do is, first we do this, 39 to 45. We're just being a little, why are we doing this, guys? 39 to 45 and not the exact number? Any idea? So, yes. Sriram has a very good question. Here we are able to apply substring as we know the file format. So most of the times you will be knowing what file format are we having, right? The data set may not tell you what this is, but data will be dumped in a specific format. So you will always have that. So some way or the other you'll be able to figure out what value is what. Though it may not be written date here, but you'll be told that okay, this is delimited by a comma, or it is not delimited by anything. It can be completely splitting. Right? Is that clear, Sriram? Okay. Well, this is not a structured file as such, right? It is actually unstructured data, right? There is a log file, right? There are other things like if you have image file, what do we do then? Don't worry about that question now. I'll answer that question next time. Okay, Sriram? For now, okay. Sachi is asking same temperature, the numeric data, then why the output parameter has to be set as text? The output of this program I have not yet defined. So I have not told you what I'm going to dump, right? I'm not going to dump, right? So just hold on. Okay, yes. So now what we're doing here, and the reason why we've taken a range, it is not 39 to 45, it is 6 values, right? Why we've taken a range is because sometimes the temperature may be 33. You can have say 99, 100 also, right? So we want to make sure that we take a range in which it will come, right? To accommodate for exactly Ravi. Thank you very much. Right. And Dilip, my friend, is telling me just like cut command in line X. Exactly, Dilip. So in cut command, what we do, we take out specific columns from a file, which is delimited by some parameter. Okay. Dilip will also send us the cut command. I can also show it to you, but right now that's not required. Okay. But remember, awk and cut is something Dilip is going to send us. Okay. Yes. So it will take one line per record to accommodate extra digits. We do this, and then we do a trim. Trim will remove all the spaces out of this, and then we make it a float. Parse float will make it a float type. It is a text type right now. From a string, it will convert it into a float. So you'll get the temp max here, right? Is that clear to everyone, guys? And then we have, okay, and then we have a temp min where we'll be trimming it again. We get a temp min again. So this is how we get it. Okay, is that clear, everyone? Now what I also do here is that I put a condition which says if the temp max is greater than 40, I'll call it a hot day. So now it will be clear whether that my purpose of this was to declare whether it is a hot day or not. That's why we are using, whoever asked me that question, Sachi probably, that temperature is why are we using a text type? Okay. So what we are saying is output will be hot day and date. Okay. And value of, based on the value of this, right? If the value is this, it will be writing this. So what are we going to write? We are going to write hot day. If it is more than 40, we are also going to write the date here, and we'll also put the temperature out. Okay, these are the three things we are going to put here. Similarly, for a minimum thing, if it doesn't fall in that, there's no output for that record. Is that fine, guys? If the temperature is below 40 and between 10 and 40, there's no output in this program for that. Okay. Now, if the temperature is less than 10, then we'll write cold day and this, right? Is that clear to everyone, guys? So this is the output here. Okay. Quickly, yes, can I quickly get a round of smileys? We are almost there. And then I'll also give you assignment on this. Everyone is clear? No one has a confusion here? Even the people who did not know Java are able to figure that out? For each record we are doing that, Avinash, up. Yes, Dilip, we will be sending all these, see all the code which is there will be given to you. Okay, all the code will be given to you. There are many more other programs which lie in your LMS. I'll show you them as well. Okay, so don't worry about whether I'll get the code. You don't have to note down anything. So Tushar is saying I could understand even if I don't know Java. Very nice. That was the purpose of this small exercise. This example is clear, but I'm not clear. Will be so structured that we know the exact location. Okay, so Vamsi, don't worry. I'll show you more examples on how to do that. Okay. Now this data is a real data. This is not something DRB or something which you have created, right? We got that data from a real location, right? You remember that? We got it from that particular website. Vamsi, you remember that? Usually you will be dumping that data in some format. We will be sending everything to you. Don't worry about sample code and everything. Okay. Now let's go to the max temperature reducer. This is the reduce program. Now in this reduce program, I am not doing anything. I am just dumping the values. Okay. What I want you to do, so what this means is that fn which I had defined, there's no fn here, right? There's no fn here. I'm just dumping these values. Okay. I'm not doing any function here. So it will straight away dump this. There's nothing. If I have to just dump whether it is hot or cold, I don't need any function here. Okay. But if I had to say, do something like this, where I had to say which is the maximum temperature in a particular year, or in this complete thing, which is the maximum temperature, okay, then I have to write a function max here. So then I have to implement that, and that is your homework as well. On this data set, you have to find out which are the maximum, what are the maximum temperatures in particular year. Okay, is that clear to everyone? How will you do that? Very simple. Is everyone clear on that? This homework? Can I get a quick yes? Great. Very nice. So this is the data set. I want, yeah, so let me show you the LMS, Learning Management System, show you where all these things are kept. Okay. Now everyone is asking questions that where will I find this data, recording, everything is here. So there is this word count program for Eclipse. There is the project. Okay, there's a temperature thing also here. There's a slightly different thing, but very, very similar. We'll be sending you this data set also. So all these things are there. So all these assignments you have to do. Okay, this is the program which we saw earlier, right? And you can quickly download it like this. So when you have to load this project in Eclipse, when you download Eclipse, so the complete environment will be created like this. Okay, is that clear to everyone, guys? Quickly, can I get a yes? Okay. And I also want you guys to do this on your own. Okay. I will monitor how much support you are taking from the support team. I'm going to monitor that. Okay. So now that we are here, right? Okay. So you have to do a lot of these things on your own. Okay. It's very simple. I'm sure you'll be able to do it. Next step, what we're going to do is we are going to create, how does this? Yes, so Vamsi, this is the thing, just thing which I just showed you on the LMS. If you download this part, it will show you how to set up MapReduce on Eclipse. This guy is going to do this. Okay, Vamsi? Great. So let's get back to the class once again and see what we're going to do next. Okay. Now the next thing is, now that you've created this program, we will be creating a Java archive of it and we'll be running it on our Hadoop. Okay, that's the next step we're going to do in this class. Okay, isn't it exciting? Now we're going to actually run this program on Hadoop, on our cluster, on that data set which we had. Okay, so the complete process will be completed and then we'll go to the next things. So let's go to our cluster now. Quickly look at the process of creating a jar. I'll also be sending you a quick video which will show you how to create a jar out of it. Yes, Vamsi, thank you very much. I'm getting a little late for the doctor's appointment. Thank you very much for your concern. I'll just take 5 more minutes and then after that I'll take a break. Okay. So what I'm showing you here, look at this clearly. We are creating a jar file out of this. Okay. So this is a jar file. Okay. I will also be showing you. So this is the jar. In this path we are creating it. I'll also be sending a quick video of how to create a jar file and a document as well. So don't have to worry too much. I'm just showing you how it is done here. Now let's look at which is the main class of this jar file, right? So we are looking at the weather data. Is this clear to everyone? Quickly, yes. Thank you, Vamsi. Thank you very much for your concern. An old man will give you a lot of. Okay. Yeah. So let's look at this. Let's look at this one. And this is the jar which we've created. Now, what are we doing here? We are FTPing this into our cluster. So this is the FileZilla thing. We put it from here into our cluster, right? And in our cluster, we'll see that we are able to see this or not. So we got it here. Is this cool, guys? Is this clear to everyone? What we did, we created a jar file, exported it from our system into the cluster, and this is where we got it. And this is the jar file, this is the data set. Okay, so the data set is weather data 2. Now let's look at the data set quickly. So this is the data set which we are looking at. These are the dates and the temperatures here. Okay, now we are going to do a Hadoop DFS. You remember this? We showed it last time. Copy from local. We'll copy everything into DFS here. Right? Is this command, you remember this command? Let's look at this in a file system now. This is our HDFS file system. We got this file here. Great. Quickly keep on writing yes, guys. If there is some confusion, just keep telling me. So what we did, we copied this jar into our HDFS. We copied the text with the input file into our HDFS. Okay. Now we are going to now we are going to do this. Yeah, so now we are going to run that program. What was the Hadoop jar? Now what are the inputs and outputs there? arg0 and arg1, input file path and the output file path. Right? You remember this now? These will be the arg0 and arg1 in our program. Right? Cool. Very nice. So yeah, let's run this program and see what is happening. Okay, so now it has started running. Ramesh, I'll tell you that as well. Okay. So Ramesh, I'll tell you that, not now. Okay. Now let's look at this. What have we got? We've got one. Okay, great. So it has told me these are the cold days. Okay. It didn't find any hot day because probably the number which we've set is a large one. It would find only cold days. Okay, that was the data set on which we had that. So this is how a sample program runs on Hadoop. Is this clear, guys? Everyone, the steps? Great. Wow. So now I know some of the things will not be very clear. Sachi, I'll take your question just a minute. Okay. Rajat is saying it's not clear. Rajat, please ask me a question. And what I'll do is, for today we will stop here and we'll go into more things. Where is the class name? Okay, show him the class name from the Hadoop jar. Okay, good. So last time we saw that. Okay. So here's the, no, don't worry. I'll show you the class name. So this is the class name here. Now let's look in that jar file. Last time we looked at all the classes which are there in the jar file. Okay. This is the class name here. Okay. Just, okay. Now there is a way to show you that. I'll show you later. Okay. Just, this is the class name which we used from that jar. Since the jar had only one class, it ran the default thing. Is that clear, Rajat? Yeah. So Dipankar, you will get all these things easily. Okay, don't worry. You can get touch base with Rajiv. He'll give you all this. Okay. Rajat, is it clear? Great. Okay. So everyone is clear with what we have just done. Let me quickly tell you what we have just done before I rush out. Okay. And I'm really sorry, guys. I had to leave today a little early. Next time I'll compensate for this one. Okay. So what we did today was we understood, quickly keep writing yes or no. I'm not taking a quiz also today. Next time I'll take a quiz on all these things. So quickly we saw where the applications of a MapReduce kind of program will be required. We looked at a large data set. Okay, you were supposed to ask. Thank you, Rahul. Thank you for that question. I'll ask that question next time. You remind me that next time. Okay, I'll show you a larger data set and I'll show you what to do. I'll also send an email on this today evening to everyone. Okay, so what have we done today? We have quickly looked at what all is. We started with a large data set. We saw a weather data set. Then we looked at what are the traditional ways of doing it. Our friends have promised us that they'll send us awk and cut there, right? So who are our friends? Can they quickly send me a smiley? You're going to send me the awk command on this data set to do this particular operation which I've done through Hadoop. MapReduce. Dilip has given me a smiley. Ravi is hiding behind somewhere. Ravi is saying not me. Ravi, you have to send me that awk command here. Okay, Avinash is also going to send me that. Okay, so same thing has to be done in awk. Okay, and yes, Vinay, we will have a MapReduce class only next Saturday as well, right? So we will extend this further. I'll tell you what I'm going to cover there. Okay. Now, some of you guys were also supposed to write a blog last time, right? So, okay, no problem, Ravi, no problem, Ravi at all. Okay. So yeah, so we will be integrating a forum also. And thank you, Ravi. Thank you very much. So Ravi is telling me I will show for sure this blog thing. Okay, thank you, Ravi. So so now what I want you guys to do is, see, one exercise, if you don't mind, will be to write a blog on this class itself, whatever you learned here, right? Step by step, you can tell us. So simple thing could be take a quick data set, use awk to do this traditionally, then use 2 examples and show us how does MapReduce work, and then write a program and then create a jar file and then do this thing, right? Whatever we have learned today, if you write a blog out of this or a document out of this, I'm sure you're going to learn everything out of it. Is that a good idea, guys? Can you find out some 2 hours today after this class? Everyone, can you promise that? After this class, you'll write down whatever you've learned today quickly after this class, okay? And you send it to me. I will look at each and every one and I'll send my review comments, okay? So you can send it to, right? So please write whatever you learned today, okay? Write it back to me. I will correct that as well. If there is anything I see that someone has not understood it properly, Gaurav, Rajat, everyone, Amrish, everyone has to write this, okay? And send it to me, because this is a very, very important concept. Lot of things, Dipankar, would not be very clear if we lose this here, right? So everyone, please. Okay. So do it on Sunday. Dipankar is saying I'm going to a lake. Okay, sure. So please do that. Send it back to me. I'll review that. Okay. Okay, guys. So I think this is it today. Now, okay. This is it for today. Thank you very much for your time. I'll be right here back with you this same time next week.